Chapter 1, Section 7, Transformations of Functions. For each function, sketch a graph of each function for c equals -3, -1, 1, and 3. For today's purposes, we're just going to use c equals -3 and +3. So for function a, f of x equals the square root of x plus c, I'm going to replace c with -3, and then I'm going to replace c with +3. So I have the two functions, f of x equals the square root of x minus 3, and f of x equals the square root of x plus 3. And I'm going to show that with our graphs, we're going to see that there is a vertical shift. So we graph the first one, square root of x minus 3. That means we start at -3, 0, -3. And then I start putting in perfect squares for x because that makes my finding of points much easier. And I make sure that what's underneath the radical is always positive. So if I put in 1 for the square root of x, that's going to be 1 minus 3, which is -2. So I have a point at 1, -2. Now my next perfect square is 4. So I put in 4 in for x, and I get the square root of 4 is 2, minus 3 is -1. So at 4, I'm at -1. Okay, I can see what my graph is looking like. It goes and it curves like this and goes out this way. So there is my f of x equals the square root of x minus 3. Now I'm going to graph f of x equals the square root of x plus 3. Okay, this time I know I'm going up 3, 1, 2, 3, and there's my first point at 0, 3. I'm going to use the same x values as I did in the previous function. So I put in x is 1, and the square root of 1 is 1, plus 3 is 4. So my second point is at 1, 4. Now my third point, I put in my next perfect square, which is 4. Square root of 4 is 2, plus 3 is 5. So at 4, I'm up here at 5. And I see that when I graph my function, it looks to be parallel to the previous function. Okay, now let's look at function b. F of x equals the square root of x minus c, which I'm going to graph f of x equals the square root of x minus a -3, and f of x equals the square root of x minus 3. Now I know that a minus negative is going to give me a plus positive, so I'm really graphing f of x equals the square root of x plus 3. Okay, now I know that this is going to move, or I should see that this is going to move to the left. Now I need x for my first point to make whatever's underneath the radical be 0. So that would be -3. So when x is -3, y is 0. Okay, my next number that I can use is -2. -2 plus 3 gives me +1, and the square root of 1 is 1. So I have my second point. Now my third point is going to be a little trickier because I have to come up with the next perfect square. Well, I know my next perfect square is 4, and that means I need to add 1 to 3 to get 4. So 1 plus 3 is 4, square root of 4 is 2. So my other point is right here. And if I graph my square root, it looks like this. Okay, now I want to graph the other one, square root of x minus 3. Well, if the first one went to the left, then this one must go to the right. So let's see. Yes, if I put in x is 3, that's going to make 0. So my first point is at 3, 0. Okay. The next point I need is going to have to be a positive number. So I'm going to have numbers bigger than 3. So the next perfect square that I'm looking for would be 1. And I get that by putting x equals 4. So 4 minus 3 is 1, and the square root of 1 is 1. And there's my second point. Now the next perfect square I have is 4. To get 4, I have to go all the way over to 7, because 7 minus 3 is 4. So 7 minus 3 is 4, square root of 4 is 2. So 1, 4, 5, 6, 7, 1, 2. And there's my third point. And if I look at it, it is also like the last one. It's parallel to the previous one. Okay, function C, f of x equals the square root of x minus 3 plus negative 3. And f of x equals the square root of x minus 3 plus 3. Now we know this plus negative over here is just going to be minus. So from what we've seen in the previous problems, I can tell that the transformations for the first function is going to move to the right, and then it's going to move down. And in the second function, it's going to move to the right, and then it's going to move up. So let's go ahead and do the first one. If I put in 3 to make that 0 underneath the radical, I go over 3, and 0 minus 3 is negative 3. 1, 2, 3. And my first point is right there. Okay, my next point, or my next number for x will be 4, because that'll give me 1, which is the next perfect square. So 4 minus 3 is 1, square root of 1 is 1, minus 3 is negative 2. So my next point is right here. Now the third point that I need what's underneath the radical to be 4. Well, that would be 7 minus 3, which gives me 4. Square root of 4 is 2. Minus 3 is negative 1. So at 7, I'm going to be at 1. So my function, my square root function, looks like this. Okay, now let's graph the second one, where I have the square root of x minus 3 plus 3. I'm going to use the same x values, so my first x value is 3, except for this time I'm going to go up 3, because that's my vertical shift. And on my second point, I put in 4, which gives me the square root of 1 plus 3, so that means I go up to 4. And my last point, I'm going to go 7 minus 3 is 4, square root of 4 is 2, so that's going to be at 5. So my function looks like this. Again, they look very parallel. This time, instead of graphing all the points, we're going to discuss what happens to the points. So my first one, A, I have y equals f of negative x. Well, that says that all the x's are going to be negative. So I would change all x values to their opposites. In other words, I would have 4, 2, 2, comma, negative 2, 0, negative 2, and negative 6, 2. Those would be the transformations of all the points for A. If we do B, we know that's going to be a vertical shift of +4. So that gives me the points -4, 6, -2, 2, 0, 2, and 6, 6. And those are the transformations for B. The transformations for C are going to be doubled. So it is a vertical stretch. So that's going to give me the points -4, 4, -2, -4, 0, -4, and 6, 4. And those are the transformations for C. Now, you try the rest of them. Identify the parent function f, describe the sequence of transformations from f to g, sketch the graph of g. Use function notation to write g in terms of f. Well, first, f of x is equal to x squared. Okay, so that means that we have a quadratic with a horizontal shift right 8. Okay, and that gives me the new function g of x is equal to f of x minus 8 squared. Okay, let's graph this. We know it's a transformation and it moves to the right 8. So my vertex is right here. Okay, then I just start putting numbers in. So if I put in 9, that's going to be 1. If I put in 10, that's going to be 4. And I know since it's a quadratic, all of these points reflect. So that means I have a point here, and I have a point here. And I have my quadratic. Okay, this time we have an absolute value function. Which means that is f of x equals the absolute value of x. And that means g of x equals f of negative x plus 3 plus 9. Now to graph this, I know it's going to shift over to the right 3. And if I put 3 in for x, negative 3 plus 3 is 9, is 0 plus 9. So my first point is at 9, 3, 9. My next point, if I put 4 in, that's going to be at 10. And I know that absolute values have a reflective property, So I have another point over here. So I have my absolute value that looks like this.